Well, welcome back. We've got a great topic tonight. These are called square root equations, and these are a big part of our exam. You are definitely guaranteed to see one of these come June time. So take good notes. All right, so here are the steps in solving square root equations. Now we want these in your notebook. List them out very neatly. Step 1, isolate the square root. Your goal is to get it by itself. Step 2, wrap each side in parentheses. And step 3 is to square both sides. Solve for x, and then check in the original. So pause it and take your time to copy these down. So here's one of the main keys. When you take a square root of something and you wrap it up and you square it, here's the beauty. They undo each other. The square and the square root, let's make a note, undo each other. So when I square a square root, I'm just going to get the number 4 or whatever's under there. If I have the square root of x plus 5 and I wrap it up and square it, again, they undo each other and I just get x plus 5. So we're going to run through quite a few practice problems, so get that pencil ready to go and get your calculator active. Exercise 1. Solve each of the following quadratic square root equations, which are arranged from less to more complex. Check each equation by using the store feature on your calculator. So letter A, this is as simple as it's going to get. Radical x equals 7. So step 1 was to isolate the radical. Is the radical by itself? Yes, clearly there's nobody on this side with it. So step 2 is to wrap them up, okay, each side in parentheses. And to undo a square root, we are going to square both sides. Now the square and the square root cancel each other out, and you're left with x equals 7 squared is 49. Now, checking is not an option. You have to check to make sure your answer works. So I'm just taking this, and I just want to be clear, we are plugging it back into the original. So I get the square root of 49 equals 7. The square root of 49 is 7. 7 equals 7, and this answer checks. So in our set notation, we are just going to put 49. B. Let's follow the same steps. Isolate that radical, get it by itself. Well, again, this radical is by itself, so that first step is simply done for us. All right, now wrap them up in parentheses, both sides. That part's not an option. And to get rid of a square root, we're going to square both sides. Again, the square and the square root cancel, and I'm just left with x minus 3. 5 squared is 25. Solve for x, and x equals 28. Now remember, you have to check back in the original. So I'm going to say the square root of 28 minus 3 equals 5. That becomes the square root of 25, and 5 equals 5. Therefore, it checks, and the only solution is 28. Okay, remember, these are going to get in order of increasing difficulty, so they should be getting a little harder each time. D. 3 radical x minus 4 equals 20. Now there's a lot of work to be done in this one before I go around squaring both sides. Remember, step 1 is to get the radical by itself. So we just have to slowly move terms over. The first thing I would do is add 4 to both sides. So I get 3 radical x equals 24. Is your radical by itself yet? No. I have this 3 in front. And that says 3 times radical x. So to undo multiplication, I'm simply going to divide. So now I get radical x equals 8. At this point, my radical's by itself. I'm going to wrap her up in parentheses both sides and square both of them. Those will cancel out, and x equals 64. Now that doesn't mean that's the answer. You have to check. So I'm going to check in the original. So I'm going to say that's 3 radical 64 minus 4 equals 20. So that's 3 times 8 minus 4 equals 20. 24 minus 4 is 20. 20 equals 20. And very nicely, 64 does check. All right, we're building to the tougher ones. All right, now here's where they get exciting. Is the radical by itself? Hopefully your answer is yes, and you're thinking, Mrs. Hill, this isn't any more difficult. But watch my next step. Okay, since that radical is by itself, I get to wrap each side up in parentheses and square. Now here's where the harder part comes in and why it's more difficult. That of course cancels and you get 2x minus 3. But how do you square this side? Alright, it's not just a number you can square in your head, it's the quantity x minus 3. So you have to say, well, that really means x minus 3 times x minus 3. So this requires some more work. I get 2x minus 3 equals, this is back to FOIL, x squared minus 3x plus 9. I'm going to clean it up. 2x minus 3 equals x squared minus 6x plus 9. I'm going to subtract the 2x and add the 3 over. So I get 0 equals x squared minus 8x plus 12. Now I'm going to factor. So I've got 1 and 12, 2 and 6, 3 and 4. I'm going to go with 2 and 6. X and x, 2 and 6. I need to multiply to a positive, that means they're the same, and add to a negative, that tells me they're both negative. Tee it up. I get x minus 2 equals 0, therefore x equals 2. And x minus 6 equals 0, therefore x equals 6. Now, we've got two solutions, so that means we have to do 2 checks. I've got to check each one in the original. Alright, so I've got to actually steal my original. That was the square root of 2x minus 3 equals x minus 3. And I have to make sure they both check. So let's first check x equals 2. Okay, if x equals 2, I get 2 times 2 is 4 minus 3 equals 2 minus 3. 4 minus 3 is 1. 2 minus 3 is negative 1. Well, what's the square root of 1? Is 1 equal to negative 1? No. This answer does not check. We have to kill x equals 2. Now let's see if 6 checks. So I'm going to write that original down again. Square root of 2x minus 3 equals x minus 3. And I am checking x equals 6. So I get the square root of 2 times 6 is 12 minus 3 equals 6 minus 3. That gets me the square root of 9 equals 3. The square root of 9 is 3. 3 does equals 3. So that does check. And that means my only solution is 6. Okay, so sometimes we're going to kill an answer if it does not check, and we're going to get one solution. Now, sometimes neither of them will check, and that's okay too. If that happened, you would just write a bracket with nothing in it. This is called the empty set. So that's okay if that happens. Alright, let's see how tough we are. Step 1, get that radical by itself. So I'm thinking I'm going to add over that 2, so I'm going to get 2x plus 2 equals the square root of x plus 6. Would you agree with that step? Add that to the other side. Alright, at this point, my radical's by itself, wrap her up in parentheses, and square, do it to each side. Okay? And hopefully you can see why this gets uglier. This side squared means I have to write it, you've guessed it, twice. 2x plus 2 times 2x plus 2. Alright, at this point I suggest you pause it, try it on your own, and see if we get the same answer. Alright, so hopefully you can follow my work here. I wrote this out twice, I FOILed it, combined my like terms, and now I'm bringing these two terms over to set it equal to 0. Now I have everybody's favorite, guess and check. Alright, so I just gotta slow down here. Notice how we're combining all the steps we've been talking about for the past 2 weeks. This term's semi-friendly because my only options are 2 and 1. This term's a little ugly because it could be either 4 and 1 or 2 and 2. And again, that's where that guess and check comes into play. I'm going to try, oh gee, I don't know. I'm going to try 4 and 1. I'm going to try 1x here and 4x here. Remember, check the outsides and the insides. 2x times 4x is 8x. 1x times 1 is 1x. Can that make a 7x? Sure, if that's positive and that's negative. So I'm going to put my plus sign here to get a positive 8x and my minus sign here. I got lucky on my first guess and check. How about you? So I went x plus 2 and 4x minus 1 equals 0. I've got to tee it up. X plus 2 equals 0. Therefore, x equals negative 2. 4x minus 1 equals 0. Therefore, 4x equals 1, and x equals 1 over 4. Now, just because I got these two answers, don't fall for that multiple choice answer. You have to check. All right, I am checking back in the original, so I've got to scroll back and get that original. 2x equals the square root of x plus 6 minus 2. Okay, so again, I am checking in here. So I'm going to start with negative 2. I'm going to let x equal negative 2. And I'm going to carefully plug this in. So 2 times negative 2 is negative 4. I get negative 2 plus 6 minus 2. Negative 2 plus 6 is 4. The square root of 4 is 2. And 2 minus 2 is 0. Does that check? Well, I would say no. Therefore, I have to kill negative 2 as an answer. Now I'm going to do the same thing and check the 1/4. So I am checking x equals 1/4. So I've got 2 times 1/4. If you can't do that in your head, use your calculator. Equals 1/4 plus 6 minus 2. Again, feel free to use your calculator. And I'm going to use mine. On this side, when I type this in, I got 0.5 or 1/2. And when I type this side in, I got 0.5 as well. So this side does check, which tells me that my only solution is 1/4. All right, exercise 2. Which of the following is a solution to this answer? Let me show you 2 ways to do this. I have 3, the square root of x over 2 equals 15. Now, we all know the first step is to get that radical by itself. So it says 3 times that. I'm simply going to divide each side by 3. So I get radical x over 2 equals 5. Wrap each side up in parentheses and square it. So now I get x over 2 equals 25. My gut says you can easily put 25 over 1 and cross multiply. So I get x equals 50. Now, how do you know if you're right? Well, basically, here's another option. Just take each of these, store them into x, and type them in your calculator and see if you get 15 as an answer. All right, but mathematically, we should have gotten x equals 50. But just if it's multiple choice, plug the answers in. All right, we're going to tackle one last big bear here. So it says, consider the system of equations. Part A, solve this graphically. So basically, I want you to throw this into y1, hit your y equals, type that in, graph it, and then we'll graph the second one. Again, if you have 2 separate colors, it comes in handy. So pause it and get those graphed with your calculator. So you can see my 2 equations. This is my y equals x plus 1, and of course this is my y equals the square root of x plus 3. Part B says, now solve the system algebraically. Well, I haven't finished part A. It says, solve the system graphically, use the grid to the right. My answer, of course, is where these 2 functions intersect. So I have them intersecting there. I'm going to say my solution is 1, 2, when x equals 1 and y equals 2. So now, like I said, it says solve algebraically. Here's the deal. If this piece is equal to y and this piece is equal to y, the 2 functions must be equal to each other. So let me say that again. If this is y and this is y, then these 2 pieces must equal each other. Okay, if they're both equal to y, they're equal to each other. So now I can say the radicals by itself. I'm going to square both sides. So on this side I just get x plus 3. On this side, remember, I'm writing it twice, and I'm foiling. X plus 1 times x plus 1. That gets me x squared plus 1x plus 1x is plus 2x plus 1. I'm going to subtract the x and subtract the 3. And I'm going to solve that equation. So I get x squared plus x minus 2 equals 0. I'm going to factor that, so I get my x plus 2, my x minus 1. Tee it up. I get x equals negative 2 and x equals 1. Now, remember, you're not done until you check. Now, look at my graph. Did I get two solutions? Did I get a solution at negative 2 and at 1? No, I only got a solution at positive 1. So I know based off my graph, negative 2 is not going to work. Now again, I could plug it into the original. X plus 3 equals x plus 1 and check. If I plug negative 2 in, negative 2 plus 3 is 1, and negative 2 plus 1. I get 1 equals negative 1. That does not check, so I'm rejecting that answer. Now 1 should check. And if x equals 1, to get the y value, I just plug it back in. 1 plus 1 is 2. Well, that does it for us tonight. Hopefully you've taken some great notes, and we'll look forward to practicing tomorrow. Have a great night.